Problem 15.12 states that the collar P slides outward at a constant relative speed u along the rod AB here, which rotates counterclockwise with a constant angular velocity of 20 rpm. Knowing that r, the position of it here, radially outward, is 250 millimeters when theta is equal to 0 degrees, and that the collar reaches B when theta is equal to 90 degrees, wants us to determine the magnitude of the acceleration of the collar P just as it reaches B. So we're given that u as a constant, which means that a sub p slash f is going to be equal to 0. The omega is 20 rpm k, which turns out to be 2/3 pi radians per second in the k direction. We need to calculate or determine what u is equal to be able to find the acceleration of p. Well, u is really the change in r divided by the change in time. The change in r is 250 millimeters. The change in time we can get by looking at theta dot. Theta dot is equal to d theta dt r delta theta divided by delta t, which means that delta t can be written as delta theta divided by omega. Well, delta theta that's taking place is pi over 2, and omega is 2/3 pi raised. So this comes out to be 3/4 of a second. And so our u is then going to be 3/4 of, going to be 3/4 divided into 250, which turns out to be this right here. So we're going to write out the acceleration p then when it's in a vertical position. It's going to be acceleration p prime plus acceleration p with respect to f plus a sub c, Coriolis term. It's this first term right here. This one is the alpha crossed r plus omega crossed r. Alpha is 0 though, so we got the omega crossed r term right there. Now my r in this particular case is going to be 500 millimeters in the j direction. A sub p slash f we said was 0, and then a sub c is going to be 2 omega crossed into u, and when you do these products you're going to end up with minus omega squared rj for this one right here. And this one, since u is in the j direction, omega is in the k direction, we're going to get a negative I out of that, so it's going to be minus 2 omega u times I. You plug your numbers in and you get this right here for your answer.